Good afternoon, everyone, and welcome to Building Trust Brick by Brick, exploring the landscape of modern secure supply chain tools. In this talk, we'll touch base on what is that we mean by secure supply chains for software and some of the modern tooling that will allow you as a software development team, both in producing and also consuming software artifacts securely and safely. Um, We are a team in Microsoft as Industrial Solution Engineering. My name is Dasith. We've got Juan and Jason here as well. We are presenting this in individual capacity, so these opinions are our own. We're not representing anything from Microsoft here. Um, the Industrial Solution Engineering team we work with, we are aligned with government and defense. So secure supply chains have been a major focus area for us in the last 6+ months. And we wanted to share some of our learnings and some of the things that you can easily do to ensure that you produce things in a secure way and consume things in a secure way. And to start us off, introduction into supply chain threats, some of the things that are very much in the spotlight at the moment. We look at how you can use some of the modern tooling in the producer side when you're developing software, we're producing software artifacts. We'll look at a very modern way of sharing those software artifacts and supply chain evidence and things like that to a consumer. And on the consumer side, on the other side of the fence, how to consume those artifacts and evidence safely. And we'll also take questions at the end. Um, so to start us off, software supply chains, what is it? So comparing it to a traditional supply chain, we've got raw materials coming in, going through a manufacturing pipeline, delivering it to a store and the consumer using it. Contrast that to a software supply chain. Your material is your source code and your open source dependencies, your other dependencies. Manufacturing through a build system, so that analogy, and then delivering it through a network to some sort of repository, and that's what's going to be consumed and deployed and run. And why are we talking about supply chain security? Well, it turns out that everyone's using more open source these days, to the point that I don't think anyone who's listening in is developing software without using some sort of open source dependency. And this means that as software developers and software development teams, we need to be cognizant of the kind of threats that are posed by the consumption of open source, because open source dependencies are great, but how do we consume them or use them to produce software in a secure way? So this is your typical software development lifecycle where you get source build and package and send it to a consumer. As you can see, all the way from consuming the source code to getting dependencies, there are different threats at every step of the way. And this means you need to understand them, and you need tools and workflows to mitigate, or at least reduce the risk of some of these threats. And if you go to this salsa.dev, you'll be able to see all of these threats. We will cover some of them as we go through in the later slides. On the consumer side, though, the main threat faced is impersonation, in the sense that you think you're consuming something produced by a person, but it's something completely different. And this is a factor, especially on the internet. Just because you get something from a trusted source doesn't mean you should trust the package. There should be a different mechanism that allows you to trust the package independently of where you get it from. And this is the workflow we'll be covering. A full left to right workflow. It's a bit complicated, but don't worry, we'll go through one step at a time. And to start us off, we've got Juan talking about the producer focus side.
Thank you, Dash. I'll be flagging you when we have to jump to the next slide. So my name is Juan Burckhardt. Today I'll be talking about the left side of the diagram that Dash presented, basically securing your materials. What I will do here is basically I'll go through a set of well-known hacks that occur, and I will point out two different tools that you can use to prevent it from happening. Not prevent it, but at least mitigating the impact of the hack, right? So for that, let me start with the first one. That is this one from Stephen Lacey. It occurred by some impersonation that a bad actor basically what did started to create a repository, started to act as different developers, well-known developers, and started to affect well-known repositories. So in this case, remember that the repositories, the spam is not only for emails, they can also occur when you're talking about development and software, right? So if you go to the next slide, how could you prevent this from occurring, or how can you mitigate the impact? What you would do in your own environment is basically you will enable commit signatures. What you do here is adding a cryptographic validation to your commit, saying it was me, I did it, right? You have seen in GitHub or GitLab that there are these verified tags. That's what you're after. In your main branch, what you would do is say no commit can get into my branch that is not verified. So you can trace back who committed, what change was done to your flow, to your logic, and which other library was included. So that's on the commit signature. If we go to the next one, now we're going to talk about this other hack, the event stream hack. This, if you don't know about it, basically there was a bad actor that pick up a repository that was stopped, the person that created it stopped developing on top of it, and he said, hey, I can take it over, I will fix some of the issues and I'll maintain it. He gave all the keys, he gave all the access to this actor, and unfortunately he went after the crypto wallets of people. If you go to the next slide, there's no easy way to mitigate or to prevent it from happening. So I'm going to talk about SAST and DAST. So static analysis and dynamic analysis, something that should be in every pipeline. You have to secure your materials. Static analysis or a dynamic analysis is as simple as configuring. Let's talk about things like a super linter or the GitHub linter, or things like secret scanning or dependable. Really easy to configure. And it won't prevent if you go and reuse that tool, but in your CI, it will be able to run a scan and smell any bad actor or any code that is has a vulnerability to report it. You have to pin your libraries that will come by a link. And the way that this will work is that if you pin your libraries, your code will be static, your commit will be static. And if you rebuild, you will be able to see any vulnerability that comes ahead. So remember, the commit, your code is static, vulnerabilities are dynamic. So it's a good practice to have in place. We go to the next slide, please, Das. PR. I don't know what to add here. If there's one actor and you have a one PR approval, it's going to go ahead. So please add at least 2 reviewers. It's really easy to do it. Any tool that is using Git will be able to help you with this one. So I won't spend much time, but I will jump to the next slide that is really interesting. Here I'm going to talk about this BOM, software bill of material. Pretty sure everybody here have heard about the Log4j hack, and you won't be able to prevent it. As in, you consume one library, but probably it's not directly this one. It has a child library. So what you will be able to do is mitigate it. So if you go to the next slide, the way that you will do it is could be easily done when you create a SBOM, a software bill of material, that basically is a manifest of your code that will tell you exactly what is living with your code, what is the dependency, and any child dependency that's on top of that. The main roles of a SBOM is basically transparency, security, and compliance. Transparency, because you can see exactly what is in there. Security, because once you know exactly what is in there, it will be really easy for you to generate security assessment or report any vulnerability on top of that manifest. And compliance ways is really good because you can also see all the licenses that have all these child libraries. So if you go to the next slide, please use it. Don't find excuse, don't create it, will be in the next sprint. It's really easy. It's one commit, multiple language supported, multiple tools exist for it. You can directly generate this form, attach it to your artifact, even sign it directly. I think that will touch more about that in a minute, but please use it. The next slide, I will talk about the well-known SolarWinds hack. So if you're not aware what happened in here, basically a bad actor got access into a network. once it got access into a network, got access into build agent, and then added the script. Bad luck. So if you go to the next slide, please, that's what you there's no easy way to prevent that, right? They got access to your agent. It's really difficult to know that. But what you can do is this thing that is called provenance. Provenance eventually, sorry, that's if you can turn the next one. The provenance, what it does is basically describe how an artifact, how this package was built. There are multiple ways to do it. Well-known packages are already there, so there are GitHub Actions, Docker ingested inside the buildx. Azure DevOps have it. If you go to GitLab, they also have it. So all that it does is give the structure or give you a statement, a snapshot of what was the build agent, right? It won't prevent you from the SolarWinds hack, but it will allow you to find out which other package was built with that build agent and how that package was included in there. With that, I think I'm done. I hand it over to Judas again. Any questions, please, at the end?
Thank you, Juan. So Juan spoke about how to produce an artifact securely and reduce some of the risks around threats in that on the left side. But we still have to get that artifact to the have a mechanism of allowing the consumer to safely consume that artifact and to verify where it came from. And in this example, so Webbing Networks are producer and Acme Rockets are consumer. We have a software artifact, and the way that we allow the consumer to verify it came from us is by signing, and we do it by having a key pair. We then give the public part of that key pair to Acme Rockets, the consumer. We sign the artifact using the private key, and then then Acme Rockets is able to use a public key to verify the package was indeed signed by us or Webbing Networks. And this is important because it doesn't matter anymore where the artifact came from. It can come from an insecure location. They can still verify that it is indeed was produced by someone they trust. So there's multiple ways signatures can be put with the original artifact. One is to embed them, like in the case of like a Windows exe, you would have seen signatures in there. This is good because it's in one place, it's one package, but it's bad in the sense you have to get the package to verify it is indeed signed by someone you trust. So the act of getting it, there are multiple attack vectors where memory leaks and stuff off the tool verification tool. The package, once it's in the target area, it's always a risk. So this is not ideal. The other way is to have the signatures detached, so you can look at the signature first and then get the artifact. But if the signatures just by itself, it's not very useful either because it doesn't claim anything about the package. Someone can just add a signature. The best way is to have this thing called a statement. Think of it as a set of claims accompanying the signature. So you can look at the claims and say, okay, this trusted party have signed this with this statement and claiming these things about this artifact, how it was built, the software bill of materials, etc. That's what we generally call an attestation. And the tooling for that is Notation or the CLI from Notary project. And this is a joint venture by Microsoft, Docker, AWS, and it's a CNCF project. It's very easy to use to sign and verify stuff. Alternatively, there's this tool called Cosign. It's part of OpenSSF, and it uses the in-toto spec for attestations. You can use either of these tools to kind of sign your build, your software artifact and any accompanying supply chain evidence. And I keep talking about artifact, but isn't it just a container image? Well, it's complicated. It used to just be container images, but now there's Helm charts, there's software bill of materials, there's provenance, there's also signatures. All of these are detached individual assets, and you need a way to put all of that in the container registry. So luckily, there's this change to the image manifest that allows us to do it. For historical reasons, it's still the image manifest, but we can now store other things in there. So we don't call it a container registry, we call it a artifact registry. And this tool called ORAS, or OCI Register as Storage, allows us to put all of our content there and have this nice tree structure by linking artifacts to one another. And it uses something called the reference API. This way we can have everything linked, but as individual detached packages. And this is awesome for the consumption side. And to talk more about the consumption, we've got Jason.
Cool. Thank you, Daz. So yeah, I'm going to talk about the consumer side of things. So in this scenario, I'm going to be Acme Rockets. Now I want to ingest a package that's produced by Web App Networks. So the first step is the ingestion of the actual the artifact that we want to reuse inside our organization. So things that we want to check before we ingest is signatures, the provenance, SBOMs, and basically everything that Daz and Juan talked about. Some tools that you can use is, again, notation or cosign, or you can also use the open policy agent to enforce your organization policies. So next slide. So an example workflow. So say you want to ingest an artifact. First step is you take a copy of that artifact into your organization. You put it into I guess an artifact store A. This is sort of like a quarantine sort of registry. The reason why we do that is because we want to take a copy of that artifact at that point in time when we don't want to keep pulling from latest, basically. And then what we want to do is we want to deploy into a UAT environment just to test out the package and just ensure that it's it actually works and does what we need it to do. So we run in UAT. If it fails, we do nothing. So we don't want to ingest something that doesn't work, that doesn't meet our criteria. But if it passes, then we push it into store B. And then once it's in store B, that means that other teams within the organization, or even our team, or the team working on a particular product, can reuse that artifact. So you may even, if you're building like a Docker container, for example, you may use that image or that artifact as like the base layer of your container. And then what you'll do is you go back to step 2 and you test in UAT and you do that process again. So what about vulnerability scanning? So we got SBOMs, or software bill of materials that was provided to us by Web App Networks. It's not enough just to scan it once. You have to scan it on a recurring basis, because at the time of ingestion, the vulnerabilities, well, known vulnerabilities at that time may not exist, or the severity of those vulnerabilities might be low enough that the company is willing to swallow that risk. But in saying that, 3, 4, 5 months down the track, a vulnerability might pop its head or rear its head up, and all of a sudden you got an issue because now your application that you ingested 3 or 4 months ago now contains a high severity vulnerability that needs to be mitigated. So there are certain things that you need to do within your organization, and that's create reports and quarantine policies in place so that the risk of those high severity vulnerabilities within your tech stack is mitigated and can be dealt with on a timely basis. So there's a couple tools that can do this really well. Most of them are open source, so Trivy and Gripe, as well as Sneak. They're all great open source tools. And as well as that, you also got Microsoft Defender for Cloud and Azure, which can do these vulnerability scannings, which is pretty sweet. And there's a bunch more. But in saying that, so I guess the last line of defense is before you deploy into your production environment or into your environment, and that's having an emission controller. And this emission controller is basically the last line of defense. It enforces the policies that you may have within your organization. So you want to verify and check before you deploy that, the whatever artifact that you're deploying has been signed with the non-public trusted key, that the vulnerability report doesn't contain any high severity items, and and that sort of stuff. So there's a couple tools that you can do this. If you're deploying into like a Kubernetes environment, there's Open Policy Agent using Gatekeeper and Ratify. Ratify is a pretty sweet tool. Basically what it does is it can check your container image or your container contains a notation signature or a cosign signature. And if it doesn't contain those, then it basically just prevents those from being deployed into your cluster. There's also Keyvono, I think I'm saying that right. That can also do basically the same thing. So just a quick scenario. So let's say you have a container registry and you have a Kubernetes environment. So you want to deploy something that's inside your artifact store B into your cluster. When you do like a kubectl apply or when you use Flux to deploy into your environment, Ratify and Open Policy Agent will basically intersect that call. It will check to see if the images that you want to deploy is valid or not. If it's not signed by a public key that we've sort of whitelisted in our organization, the deployment won't go through. It'll just stop right there. But if it was signed and we're happy with it, then it'll go ahead and deploy into your cluster. So that's the consumer side of things. I'll pass it back over to Des.
Thanks, Jason. So just to reiterate and wrap up, so things you can do if you're producing software either as an open source project or in organization. Generate the software bill of materials. Start doing this today. Add the provenance, which is very easy. It's just a task you can add to your existing CI/CD pipeline. Sign and attest the things that you produce so your consumers can consume them securely. And start using OCI registries as storage. So you don't need to worry about blob storage or putting things everywhere now. You can, including your Helm charts and your manifests, everything now can go in the OCI registry. One place for everything. And on the consumer side, always verify something before using it. This might take some time to get right, but the policies and stuff, but it's totally worth it. And set up continuous vulnerability scanning, either using open source tooling and handcrafting some sort of cron job, or using a paid platform that kind of automatically hooks into your existing OCI registry and does the vulnerability scanning. And lastly, always have admission control in place. So this is a second catcher, the last line of defense. Everything you do before in terms of policy, you must also enforce in admission control to be completely satisfied that everything in your final environment has the same kind of rigor. So thank you for attending the talk. If you have any questions, please reach out to us. We're more than happy to help.